Now let's see these sums. 27 raised to 2x minus 1 is equal to 243 raised to 3, then x is equal to what? Now 27 and 243, both of them are there in the power of 3. So 27 can be written as 3 raised to 3, right? So it is 3 raised to 3, 2x minus 1, it's minus 1. And it is 243 is 3 raised to 5, so it is 3 raised to 15, 5 into 3. Okay, now 2x 3 into 2x minus 1 is equal to 15, because when the base is same, power will also be same. If a raised to x is equal to a raised to y, then x is equal to y. Okay, now 2x minus 1 is equal to 6, that means x is equal to 3. Pretty simple. Now x is equal to 19, y is equal to 18, the value of this expression. See, whenever you see the big values of x and y and this sort of expression, do not or never put the values of x and y in the expression. It will be unnecessary time wastage for you. Definitely there is some algebraic relationship or formula or expression behind this this particular question, right? Now x square plus y square plus xy, and this is x cube minus y cube. Precisely x cube minus y cube, you might have attended the basic sessions of algebra. X cube minus y cube is x plus y, x minus y, x square plus y square plus xy. So this thing is basically this thing, right? Now you can see x square plus y square plus xy is there in the numerator, so this and this is cancelled. So you are left with 1 upon x minus y, right? Now that is 1 upon 19 minus 18, that's 1. So the problem becomes very simple if you are able to crack which algebraic formula has been used over here. Okay, so be careful, never ever put the values of x and y in these sort of expressions. Let's take the next one. X square minus x plus 1 upon x square plus x plus 1 is equal to 2 by 3, then x plus 1 upon x. Now how would you get x plus 1 upon x over here? Now you see this x square and this one, x square and 1, right? Just try to recall the funda that x plus 1 upon x that we have discussed in the previous session. So divide this entire expression by x. So what you'll be getting, x plus 1 upon x minus 1 and x plus 1 upon x plus 1, and that is actually 2 by 3, right? Now since you want the value of x plus 1 upon x, what I do is I assume this to be a and this to be a to make the problem simple. So it is a minus 1 upon a plus 1, right? So 3a minus 3 is equal to 2a plus 2. So a is equal to 5. What is a? X plus 1 upon x. So that's 5. Pretty simple. I hope you are clear. A and b are rational numbers such that a plus b root 3 is 1 upon 2 minus root 3, then a is to b is equal to. Now it's very simple. A plus b root 3 is equal to 1 upon 2 minus root 3, right? Now what you can do is you just rationalize it. Whenever you see a rational expression in the denominator, first thing you do is just rationalize it. So it is 2 plus root 3, and here in the denominator it will be a minus b into a plus b format, so it is 4 minus 3, that's 1, right? Now since a and b both of them are rational number, we can just make the comparison directly. A should be equal to 2 and b root 3 is root 3, so b root 3 is root 3, so b is equal to 1. Now a is to b is what? 2 is to 1, that's 2. Okay, so that's very simple. Now see this problem. A is to b is to c is this, then the value of ax plus by plus cz. Now this can be written as a upon y minus z is equal to b upon z minus x is equal to c upon x minus y, and I assume each of them equal to k, right? Now I want x, ax precisely, so what I do is I multiply numerator and denominator by x over here, so it is x, here y, here z. Now ax is equal to what? K xy minus k xz. So what I do is I put up the value of ax, by and cz over here, right? So you can see k xy minus k zx plus kyz minus kxy plus kxz minus kyz. So precisely all of them will be cancelled with each other and you'll be getting 0. Okay, that's pretty simple. Now a4 plus b4 is this, then a raised to 6 plus b raised to 6 is equal to, what I do is I assume a square is equal to x and b square is equal to y. So I'll be getting x cube plus y cube, right? And that is actually x plus y, x square plus y square minus xy. Now x square is what? A raised to 4. Y square is what? B raised to 4 minus xy is what? A square B square. Now a4 plus b4 is already given as a square B square. So this is a square B square and this a square B square, they will get cancelled, so the entire expression will be 0. So precisely a raised to 6 plus b raised to 6 is nothing but x cube plus y cube, and this is nothing but this, so it is 0. Pretty simple. Now this problem, a square plus b square is 2 and c square plus d square is equal to 1, then value of ad minus bc, this is this. See, in this sort of question, never think much, right? What you do is just take comfortable values of the variables, right, which satisfy the given relationship, and after that just proceed. Because see, when ad minus bc whole square plus ac plus bd whole square is a constant, because a b c d, all the 4 options over here are constant values. If it is constant, that means for any value of a and b which satisfy this equation, any value of c and d which satisfy this equation, you will get the constant answer for this. So that put up any value in that case, right? Because any value will give this expression as a constant value, that put up any value, right? So what you can do is it depends upon you which type of values you wish to choose. A square plus b square is 2, then you can choose a square and b square, both of them as 1, right? So a and b, both of them will be 1. So I just take 2-3 examples over here, so you'll be able to understand this in better manner, and you'll have an understanding how to choose the values. Now a is 1, b is 1, c is 1 and d is 0, right? So AD that is 0, BC that is 1 minus 1 whole square, that's 1, then AC 1, BD 0. So 1 plus 1, your answer is 2. Okay, now we take another set of value, right? So in exam, you be confident that whatever is the procedure you are adopting, it's correct. Here a square plus b square is 2. I assume a as root 2. So a square will be 2, b is equal to 0. Here c square and d square, I just take c square as half and d square as half. So c is equal to 1 upon root 2 and d is also 1 upon root 2. Okay, now see, once again a, c, d, we have 3 values and the 4th one is 0. So the problem becomes very simple for us. AD that is 1, BC that is 0, AC that is 1 and BD that's 0. So once again you are getting 2. So be confident, you will never make a mistake if you choose the right value. Okay, so I have given you 2 sets, you can make more sets like this. I hope you are getting my point. Otherwise, if you start expanding the brackets, it will take up huge space and huge time. The question will not worth solving in that case, right? So be careful about it. Choose the comfortable values. Now this question, a square plus b square plus c square plus 3 is equal to 2a plus 2b plus 2c. So it is a simple expression. We have already done this sort of problems. See here, it is a square, just take this 2a this side, and this 3 can be broken up into 3 ones. So 1, 1, 1. So it is this, then b square minus 2b plus 1 plus c square minus 2c plus 1 is equal to 0. So precisely it is a minus 1 whole square, b minus 1 whole square plus c minus 1 whole square, that is equal to 0. Now sum of 3 square terms can never be 0 because all of them will be positive. So how can the sum of 3 positive values be 0? Right? Now the only possibility is when this sum will be 0, that is it is 0, it is 0 and it is 0. Now if this is 0, that means a is equal to 1. If it is 0, that means b is equal to 1. If it is 0, that means c is equal to 1. That means a plus b plus c is 1 plus 1 plus 1, that's 3. Okay. Now this problem, x square plus y square plus z square plus 2 is equal to 2y minus x. So x cube plus y cube plus z cube is equal to. Same problem, similar as we have just discussed. So I just take everything on this side. X square plus 2x plus 1 plus y square minus 2y plus 1 plus z square is equal to 0. This is x plus 1 whole square plus y minus 1 whole square plus z square is 0. That means all of them should be 0. As we have just discussed the concept, sum of three positive quantities cannot be 0. So each one of them has to be 0. So precisely x plus 1 is 0. That means x is equal to minus 1. Y is equal to 1 because y minus 1 is 0 and z is equal to 0. Put up the value of x, y and z over here. Minus 1 whole cube, minus 1 plus 1 and then 0. So it's 0. Okay. So that's very simple. Now this problem, a plus b is equal to 5, a square plus b square is equal to 13, then a minus b is equal to. See here it is clearly shown the values of a and b, right? 9 plus 4 is 13 and 2 plus 3 is 5. That means one of them is 2 and other of them is 3, right? So a is greater than b, that means a is 3 and b is 2, right? So a minus b can be calculated, but every time it is not possible that you will be just able to find out the a values of a and b so easily, right? So what is the another approach over here? See, a plus b is 5, that means a square plus b square plus 2ab is equal to 25, right? We squared this both the sides. So a square plus b square is 13. So 2ab is equal to 25 minus 13, that is 12. That means ab is equal to 6, right? Now you want a minus b. So what you do is a minus b whole square, that is a square plus b square minus 2ab. So you know a square plus b square, that is 13 minus 2ab, that is 12. So a minus b whole square is 1, that means a minus b is equal to 1. So this is how you can do. If you are able to find out the values of a and b just by looking at the question, then just go this way. Otherwise, this is the proper way of doing the problem, right? Now, we have this problem. Find the value of expression x raised to 5, this when x is equal to 11. Obviously, very tedious problem, involve high calculations. But this is a question from a competitive exam from the previous year paper. So there must be some logic to solve this sort of problems, right? Now what that logic is and how we can solve this sort of problems. Before I solve this problem, let us discuss the concept in detail. Now what? Any expression, suppose I take a very small expression, suppose x square minus 2x plus 1, right? Now I have two questions over here. If I divide this expression by x minus 1, what will be the remainder? Right? This is the first question. If I divide this expression by x minus 1, what will be the remainder? This is the first question. Second question, if I put x is equal to 1 in this expression, what I will get? Suppose this is px. Okay. If I put, or I can say what will be the value of p1. So there are two different questions, right? If I divide this expression by x minus 1, what will be the remainder? If I put x is equal to 1 in this expression, what I will get? What is the value that I am going to get, right? But these two are different questions, but method of solving both the question is same. In both the cases, what you will do, you'll put 1 in the expression and will see what you are getting. Suppose you are putting 1 over here, so it is 1 minus 2 plus 1 is equal to 0. That means when you divide this expression by x minus 1, the remainder is 0. And when you put x is equal to 1 in this expression, still the value of this expression is 0, right? And you can go by the normal division method also. If you don't appreciate this idea, like how do we find out the remainder when this expression is divided by x minus 1? So this is x square minus 2x plus 1. Here it is x square minus x, it is minus x plus 1, so it is minus 1. So it is minus x plus 1, so it is 0. So remainder is 0. Okay, so when you divide this expression by x minus 1, remainder is 0, and when we put x is equal to 1, still we are getting the value as 0. That means if I ask you the question, if you divide this expression by x minus 1, what is the remainder? And the other question, if I put the value of x as 1, what will be the value of p1 or this expression? Then your answer will remain same. Now the same thing will be over here. If this expression is what will be the value of this tedious expression if you put x is equal to 11? And the same question can be asked in other manner. What will be the remainder if this expression is divided by x minus 11? And I have just proved that both of them will give you the same answer, right? Because logically both of them are same. Okay. So instead of putting 11 in this entire expression, 11 raised to 5, 11 raised to 4, then multiply by 12 and blah blah blah, what I can do is I just simply divide this expression by x minus 11, and whatever is the remainder, whatever will be the remainder which I will get, that will be the value of this expression when x is equal to 11, right? If you are confused at any stage, you can take some more examples and apply both the concept, this and this, and just check whether you get the same answer or not, right? So if I divide this expression by x minus 11, whatever is the remainder, that will be my answer. Now once again, to divide this expression by x minus 11, even that is not very easy task, right? That will take huge space if we go this way, right? So ultimately when you divide this expression by x minus 11, ultimately what you are doing, you are putting a value of x as 11 over here, and whatever is the remainder, that will be your answer, right? So what we need over here, a smart technique, a shortcut by which we divide this expression by x minus 11 and get remainder in just one line, right? And in less than a minute, right? So I would like to discuss the method with you over here when we divide these sort of expression or this big expression by x minus 11 in just one line with very small calculation, and will get answer in less than a minute. But before I solve this question, I would like to discuss some small questions which should just get a grip on the method. Okay, so let's take a very small first question. Now suppose I have an expression, maybe say x cube minus x square plus 7x plus 3. I have to divide this expression by x minus 3 and I have to get the remainder. Again, I have to divide this expression by x minus 3, I have to get remainder, or what is the value of this expression when x is equal to 3. Now how would we do this division in one single line? Just listen to me carefully, right? See, if it is minus 3, just put 3 over here, then the sign opposite to this. Okay, now the first thing is, how would you get x cube? If you multiply x by x square, so it's x square. Okay, after that just take the coefficient of this, it is 1, multiply this by this and add it to coefficient of x square. Okay, and keep on doing this. So it is 3 minus 1, 2. Okay, same thing, 2 into 3, 6 plus 7, 13. Right? 13 into 3, 39 plus 3, 42. So you got a constant over here and a constant over here, but you see I didn't put the positive or negative sign over here. Precisely x cube minus x square plus 7x plus 3, if it is divided by x minus 3, that is the quotient and that is the remainder. Okay, so instead of putting 3 cube minus 3 square plus 7 into 3 plus 3, you got the remainder very easily, and along with remainder you got quotient also, right? So if data is bigger, still there is no problem. I'll just take one more example. Now what will be the value of this expression when we put x is equal to 5, or another case, what is the remainder when this expression is divided by x minus 5? And along with remainder, we are able to find out the quotient also. So in any exam, if you are asked about the quotient, then also you can find, right? So first step, just change the sign and put it over here. then it is x square. Okay, x into x square. After that the story is very easy. Just start with the coefficient of this. 1 into 5 minus 3, right? 5 minus 3, 2. So it is 2x. Just keep on reducing the power of x, right? 2 into 5, 10 plus 10, 20, right? 20 into 5, 100 minus 7, 93. This is quotient and this is remainder. Okay, so if you put x is equal to 5 in this expression, you will be getting 93. Or if you divide this expression by x minus 5, the remainder will be 93 and this will be the quotient. So how simple the story is, right? In just one line, you can perform the entire division, right? Now, after doing 2-3 questions, now I'm sure you must be clear with this method, and you can take on your some of examples from other books, or you can create your own also. That's not a difficult task, but you should be getting a good grip of on this method, right? Now we solve this particular question. Now minus 11, so I will put 11, right? Now the first step is x into x4 is x5. After that the story is very easy. 1 into now it is 1, so you don't have to consider it again and again. So it is 11 minus 12, right? We add both of them. So 11 minus 12, that is minus 1. So it is minus x cube. Then it is minus 11 plus 12. So it is plus 1. Then 11 minus 12, again minus 1, minus 11 plus 12 plus 1, 11 minus 1, 10. So this is the quotient and this is the remainder. Now how much time did it take? Less than a minute, if I'm not wrong. And how much space it is taking? Just 2 lines, right? So if you put x is equal to 11 in this expression, your answer, you'll be getting the value as 10, or in otherwise you can say, if this expression is divided by x minus 11, the remainder is 10, right? So both ways you can understand the concept, but yes, practice is necessary, so you can save your time and space as well, and you can just get a good grip on the method, right? But method is really very easy. On the similar method or the same concept, the value of this expression is, you can see this question has appeared in this exam, SSC FCF and February 2012, right? So frequently asked question in SSC exams, and you must be having a good grip, right? Here it is x4 minus 17x cube plus 17x square. See, if you get a good grip, even you should not copy this problem over here once again, right? So what you can do is you just do it directly. X is equal to 16, that means we'll start with 16, right? X minus 16, so I just take the positive value, right? Now I start with x4. The first step will be x cube. Then we start with the coefficient. 16 minus 17, that is minus 1, so it is minus x square. Then minus 16 plus 17 plus 1, 16 minus 17 minus 1, 16 plus 17, minus 16 plus 17, minus 16 plus 17, 1. So this is the quotient, this is the remainder. So how much time did it take? 30 seconds, not more than that. If I'm explaining and I'm taking 1 minute, then if you do it on your own, you will not take more than 30 seconds. Similarly, suppose you have any other, maybe x raised to 4 minus 6x cube plus 3x square minus 2x plus 5 when divided by, say, x plus 2, what is the remainder, right? Or the other question, if you put x is equal to minus 2, then what will be the value of the expression? So just put the negative 2 over here, right? Now x4, x, you need x cube. Minus 2, minus 6, minus 8. Minus 8 into minus 2, 16 plus 3, 19. Minus 38 minus 2, minus 40. 40 into 2, 80 plus 5, 85. So this is the quotient and this is the remainder. remainder when you put x is equal to minus 2 in this expression. I'm sorry, remainder when you divide this expression by x plus 2, and value of this expression when you put x is equal to minus 2. Both of them will be 85. So how simple it is, can be performed in just one line, right? I hope you are clear with this method now. Now if a plus b plus c is equal to 8 and a minus 4 whole cube plus b minus 3 whole cube plus c minus 1 whole cube, if it is we have to find out the value of this expression. Okay, now whenever you see this format x cube plus y cube plus z cube, you just try to recall that x cube plus y cube plus z cube is equal to 3xyz if x plus y plus z is 0, right? Now how do we relate that over here? I assume a minus 4 to be x, b minus 3 to be y, and c minus 1 to be z, right? So it is x cube plus y cube plus z cube minus 3xyz, right? Now instead of a, see a minus 4 is equal to x, that means a is equal to 4 plus x, right? So it is 4 plus x, similarly it is 3 plus y, similarly it is 1 plus z is equal to 8. I put up the value of ABC over here in terms of x, y, z. Now 4 and 3 7 and 1 8 and 8 is 0. So x plus y plus z is 0. So if x plus y plus z is 0, x cube plus y cube plus z cube will be 3xyz. So if it is 3xyz minus 3xyz, the value will be 0, right? I hope you are clear. Now this problem, x is equal to 997, y 998, z 999, then the value of this expression is, obviously there must be some formula to calculate this expression when we have very big values for x, y and z. Now there are two chances, either you are able to recall the formula or you are not able to recall the formula, right? But in both the cases the problem is not at all difficult, right? You see options 3, 9, 16 and 4, right? Now what you can do is you just calculate the unit digit of the expression and just match, because unit digit we have unique 3, 9, 6 and 4. The first thing. Second thing, if unit digit is not unique, then even you can go by the digital root method also, right? I just take unit digit method over here. So x square unit digit will be 9, y square unit digit will be 4, z square unit digit will be 1, x, y 7 into 8 72, unit digit is 2. I'm sorry, 7 into 8 56. I'm sorry. Then yz 8 into 9 72, so that's 2. Then xz, that is 7 into 9 63. Okay, so here it is 6 and 3 9 and 9, 4 5 minus 2, it is 3. So answer to this problem is 3, because we just have one option with unit digit as 3, right?